Hello everyone, welcome back to Android Study Jams Track 2. This is a very special session. It's the last session in the whole course. So we'll dive into it and we'll see what else we have to complete before you guys can finally start building close to real world apps and exploring more and deeper concepts in the world of app development. So this is the schedule for today. We'll be looking at session 3 quickly and we'll be finishing off the last 3 pathways in track 2. So last time we were introduced to databases and Room, which is a library that helps you connect to databases in Android and run queries and retrieve data or manipulate data stored in your local database through SQLite. And we learned about coroutines, which are basically things that help you run your code parallelly. And this is a picture from last week's slide that I think nicely sums up the whole concept of coroutines and all that it can do. Also, a bit of an extent of what it can do, its overview of its functionality and properties. And lastly, we took the recycler views, which help us display lists in Android. And for anyone who's been here since track 1, it was a revision for them as well, a refresher. So let's get started with today's session. Today's goal is like I said, is the last 3 pathways, and while completing these pathways, you'll be completing these 3 apps. The Mass Real Estate app, which is just an app that lets you look at the real estate properties of certain pieces of land on Mars. Then the Dev Bytes app, which lets you look at videos that people have posted from the Android community. And the Google Developer Group Finder, which lets you find the closest GDG to you based on your location. So after today, you'll be able to get data from the internet, display images from the internet, save data that you recently got from the internet, and maybe use it when your app is offline, or even if you want to use some data again, if you want to show the data in some other page, or you're going back to the page, instead of getting it each and every time from the same source, you can store it and bring it from there itself. You'll be able to display images as well from the internet, and you'll be able to add styles and themes to your app to make it that much more nicer. So we look at the first pathways concepts. Retrofit, talking to the internet. So just a quick background for before we talk about this particular topic. Whenever we visit a URL, which is the address we type into the search bar of our laptops or any other device, a page is loaded. And where does that page come from? It comes from servers. How is that page brought up? How does the net or the internet know, or your browser know that when you type this page, this address in this server, this page should pop up? Well, that happens through something known as REST APIs. And quickly, an API is just a little helper function that abstracts a lot of things from you. So you just call it and tell it what you need to do, and it does it for you without you having to bother about all the underneath workings of it. And you just need to know what you need to ask properly. Quick example is when you go to a restaurant and you order food, you just tell the waiter what you want and nothing else. The waiter does everything else for you. It tells the staff what you want and how to prepare all that stuff. All the stuff about preparing the food and making sure everything is right, all the ingredients and stuff, you don't need to worry about it. You just need to know what you want. And the waiter delivers it to wherever it needs to be delivered and brings back the result to you, which in this case would be food. So here the waiter plays the role of an API. And in a similar fashion, there are APIs or communication protocols for APIs that let the websites or the networks or the internet talk to different servers to get corresponding pages. So there's something called, one of the communication protocols is REST, and it follows something known as a request response cycle. So you request a page and the server gives you back in the form of a response. And there are certain methods you can use with this protocol, and there are certain status codes. I'm not here to talk about all that. This is just to give you an idea of what Retrofit is and how it's useful and how it comes into play with respect to Android. So Retrofit is a library that helps you make requests to these servers through APIs, and you can get results back and display them on the page. And JSON is another part that links back to Retrofit or REST APIs. JSON is basically a format of storing and transporting data across the net. It looks something like this. You can think of it as a dictionary if you ever use Python. So this is what gets transferred between servers and web pages, and you use it when you receive it or when you send it. The receiving party can use certain techniques to pass it and make it more readable for themselves and to display it on the page in a more human readable format. And Moshi is one library that does that. In Android, it helps you pass JSON data, just like Retrofit is one library that helps you make requests. So these two can work hand in hand to really make things calling the APIs on servers to help you get data really easy. So that's pretty much it for the concepts of Pathway 8. We look at the Codelabs now. Yep, so you can make requests to web services through what I explained as APIs. And the response you get from a web service or an API is in the form of JSON, although there are other formats like XML and such, but it's most commonly transported in JSON. And like I said, if you're familiar with Python or even Java, you can think of JSON as a dictionary or a hash map or even an array of arrays. So Retrofit is in third-party library. It's not inbuilt, so you have to add the dependencies to the Gradle file. And you'll have to do a couple more configuration settings to make sure that Retrofit can work for you. And the way you use it is you set up the base URL or the base API you want to call or you want to request data from, and you use the Retrofit library to call it and get the, like I said, you can perform different functions, one of them being get, and gets here stands for retrieving data from that particular API. So once you do that, you can call it and get the data in your code. This again is done, this ties back into what we've been learning over the past couple of weeks, which is app architecture specifically. And we talked about coroutines and things like that last week. So this is where you really get to see the power of coroutines, because if you run all this kind of code in the main thread, you most likely run into a crash or a lock, because all this stuff takes time. It could take time to load the data or get the data or even call the server. So you should make all this modular and make sure that it's not all in one place, so bad stuff like that doesn't happen to your app. So you can see they're using functions and all that to make sure it's all modular and separated and doesn't collide with any of the other pieces of code in the app. And once you run the app, you should get something like this. This is all the data, and as you can see, it's just pure JSON text, so it doesn't make much sense. And we look in the next task how we can use Moshi to pass this and make sure it's more readable. And if you see that you switch off your net or you take away your internet connection, you can see that this is what pops up. We take care of this in the code by saying we can track the success of this request, and if it's a failure, we can display the error message on its own, or we can display our own custom error message saying that you have an internet or anything that you see fit. So like I said just now, you'll get a JSON response from any API that you call, or most APIs that you call. And as you saw in the previous task, it's not exactly human readable or easy to understand, which is where Moshi comes in, and it's what helps you pass this data or transform this data into more readable format. And just like Retrofit, Moshi is also a third-party library, so you have to add the dependencies separately. So this is what a sample or a one entry of the JSON response looks like, and we'll see how to convert this into readable format using Moshi. So one thing you have to do is create a data class with the same properties as the JSON entry has. and use the certain syntax and annotations from the Motion library to make sure it's all readable. And now you see that you can only retrieve the properties that you want, and it's much more readable in that sense as compared to the raw JSON that you get. So like I mentioned in the beginning, you can use coroutines with Retrofit to make sure none of the locking or crashing happens. And you can suspend the tasks or launch them whenever you want and launch them after a certain event happens. And you can do all the things and you can settle on which works for you best. So here you can see that we're trying to get it. And in case it fails, we can show the exception, which is what we saw when we switched off the internet or any network connection and run the app again. So that's the first pathway. We look at the second one as well. So the first one was the first Codelab was about this getting data, and now this is about displaying images. So up till now we've been only showing text, and we'll see how we can show images from the internet as well. This is done through a library called Glide, and again it's a third-party library, so you have to add the database, the dependency separately. So now the one of the things that the JSON response includes is an picture URL, or the URL where the location where the website image is stored. So this is the way Glide works. You provide the context and you provide the image URL and you provide the view in which you want to load the image. And the rest of the code is just updating the existing code to fit in with the Glide changes. And this is the result. You'll be able to load the image from wherever URL you give it with the help of Glide. One more thing you could do is add certain standard messages like error messages, loading messages. Excuse me. Loading messages could be useful in the case where once you've set up all coroutines and things properly, if your code is taking a long time to retrieve data or calling the API is taking a while, you can show this image when the page loads and display the data when that comes in. Alternatively, you could show a loading bar, which is a UI component available in Android. You can even use a progress bar to show that this amount of data is retrieved or being retrieved. So last week we looked at a recycler view where you displayed a bunch of images. We can do the same thing here. Once you've gone through, by this time we would have gone through recycler views and using it thrice. So once you complete the course properly, you'll have a good understanding and good sense of familiarity with respect to recycler views, and using them later on for new projects should not be a problem at all because it's pretty much the same syntax. Every time you just need to change a couple of things and you can get started. So we just updated the code with a list of images, all from Glide, and some of them standard messages that you can show. One more thing is to handle cases where data can't be retrieved. Suppose there's no network, which is one of the more familiar or frequent errors you'd face with respect to handling data with this internet, because that's the source. So once there's no network, you won't be able to reach the server. So handling those kind of errors in each and every component of your app is a good practice, and to make sure that the users have a smooth experience. So they're adding a status to make sure that of the page, if it's loading, done, or error, and in each case they have corresponding code. So this image has been shown in the corresponding case, so you can write all that code and make sure that all the cases are covered for your app. So that's about the second Codelab. We look at the third one now. So now we're adding a bit more information to each of the pictures and displaying which parts of the mass are on sale and if you can rent, buy, or sell them, or you can show all. So this is this whole task or code lab includes just changing the code to fit in with this new features we want to add, which is one would be to include the type, if it's rentable or if it's for sale and things like that. So here you can see that one of the updates made after the code is modified is you can see some of the images have a dollar sign on them indicating that they're for sale. You can also use filters. That's another thing you can do through Room. You can use a SQL query to filter all the data. And that's another common use of Room if you want to add any filtering feature in your apps, whether that be by descending order or highest order or lowest or from best to worst, anything like that. Again, those queries will become more frequent and they'll become more standardized, I guess you can say, where you have to change only a couple of things and you get used to it once you've used them a couple of times. And this again is pretty standard in the sense we've already seen this happen in the past where you click on a certain page and you go to a detailed page with the corresponding details of the place you clicked on. Finally, this is just updating the detail page to show more details about the piece of land. This kind of thing was done in track 2 only in one of the pathways. I can't exactly remember which one, but we updated an app such that if you click on one of the images or the yes, it was for the sleep night track my sleep app. So we showed similarly we had a recycler view with the nights or the sleeps times as the lists, and when you clicked on each of them you could get more detail. So that they just tied that into this exercise to see how that can also integrate with what we've learned today. Now we look at pathway 9. So caching is the another concept that's useful for when working with data retrieved from the server or retrieved from the internet. So one of the cases you could use this is when you want to show your data to someone or on your app, but your app is offline, like the person, their net is gone or they don't have strong connection. And in case they can't reach your data, they might close the app or not use it for a while. So to prevent them from exiting the app just because your app is offline or for them to not use it, you could use something called caching, which is basically apps can cache data or store data when it's retrieved from the server, and they can use that data when the app is offline or use it when the same data is required again without having to call the server each and every time they want to show the same piece of data. There are a couple of different caching techniques in Android. They include using Retrofit, using shared preferences, internal storage, and Room. We'll be looking at Room for in this code lab, but you can explore the other ones as well. I'll provide links later on. Personally, just to mention, one of the common uses I found for shared preferences when I started out was to track the sign-in status of any user. So if you're working with any app and you have a sign-in feature, when they sign in for the first time and if they don't sign out, you don't want to have them to sign in every time they open the app unless they sign out again. So to track the status and to check if they signed in or if they signed out every time they open the app, I use shared preferences. There are better ways to do it, but with respect to the context we're talking about now, that is one of the uses I've used it for. Then the second thing we're looking at in the ninth pathway is what's known as Work Manager. It's another part of the Android Jetpack library, which we looked at quite a bit in track 2. And it's one of the Android architecture components. It also goes along with all the architecture components we talked about last week and last week as well, with the whole MVVM model of constructing your apps and how that makes things easier for you to read your app code and maintain your code. It's used to handle background work, so you can say it kind of works similar to threads in that way. And the work it used to handle is of specific type. The work is deferrable, which means it doesn't need to happen immediately, and it's guaranteed. So though it doesn't need to happen immediately, when it happens, you need to make sure that it will happen no matter what, no matter if the app crashes or the person exits the app or even removes it from the background tasks. So we'll see how that happens now in the ninth pathway. So this is what I was referring to when I said caching. As you can see, it says here it's to store the data in a device's storage, and you can access it later when the device is online if you want to access the same data again. And this table goes into more detail of the methods I mentioned already. So Retrofit is used for simple requests and responses and small data sets. Similarly, shared preferences is good for storing key value pairs. So in the example I mentioned, you could probably store the user and the status, whether signed in or signed out, or certain things like that. Both of these cannot work with large data sets. That's not in the capability. So it's only good for small things you might want to store, or not trivial details, but compact details that you might want to use or store that are important for later on. And you can also access the internal storage of the app and save the files there and retrieve them later on. And these files will only be private to your app. The OS and other things internal workings will not allow other apps to access this data. And finally, you can cache data using Room as well. And it's the best way to store complex and structured data as well. And this is what we're looking at now. So this is what the note says as well. It says not to retrieve data from network every time the app is launched. So once you've set up the room caching technique, you can load it from there itself, and this will save app loading time, and your users won't get as annoyed or as irritated waiting for the data to load as they would when you have your code retrieved from the server every time. So the solution for this is the first time you load it from the network, instead of displaying it, you could store it in the database. And every time you need to access the same data, you can fetch it from the database instead of going and getting it from the network itself. So the first thing to do is obviously add the room dependency, because room isn't built in, it's a third-party library. And all this is going over the code to perform this and add the caching technique. And this also includes some of the concepts we already talked about, like DAOs and entity classes. Just a quick reminder, entity is what represents a table in your SQLi database, and it's a data class in Kotlin, and DAO is basically a data access object, which is just a function that includes all the which is a class, sorry, that includes all the functions that will perform queries on your database. Now we look at repositories. I didn't include in the slides because I talked about it already in the app architecture session. Basically, repositories are the middleman between getting data and giving it to your app. They're, with respect to the MVVM architecture, they're in between view model and model. So a repository gets it from data from the model. Through the model, it gets the data and passes it to the view model, and the view model takes it from there. So one thing a repository also useful for is you can write the code of whether you want to retrieve data from the database directly or if you want to retrieve from the network itself. So it's helpful there as well. And this is just retrieving data from the database and adding the repository to your code. And this is the task where you retrieve the data from the database and not directly from the network using something that's called the refresh strategy. So instead of getting it each time from the network, the app gets it from the database itself and displays it directly on the screen. So with this, when you run the app again without your connection enabled or Wi-Fi connection established, you will see that the playlist itself is fetched and displayed because you stored it in the cache and it's getting it from there instead of the network directly through your repository. So that's as far as pathway 9 goes. Um, so this is the last pathway. We'll look at that quickly as well. So this path is all about styles and themes, which again is throwback or callback to track 1. It was talked about there originally, and this is the same slide I used then. To catch the people up, color is all around us. Digital and physically, you can see color everywhere, and it adds beauty or aesthetics to whatever we're looking at, all the objects we see around us. And it also adds a hint of realism to your app through the material design library or a component of Android. When I say realism, I mean through material design, you can capture textures, reflections, shadows, and other real world things that make your app that much more realistic or lifelike as possible. So the way this works is each color is represented by 3 hexadecimal numbers, and one hexadecimal number it takes up 2 digits. So hexadecimal is a number representation system, much like we have decimals and binary representation, decimal being the standard 1 to 10 and binary being 1010s. Similarly, hexadecimal is another representation of numbers, and in this case it uses 2 digits to represent one number. So as you can see here, you have the standard, you have the 6 total digits, which is 3 numbers, and there is an extra 1 hexadecimal number or extra 2 digits, which represents the transparency. So if you have FF, which means it's completely transparent, so it will become where the lightest shade of that already existing color, and you can vary the value of this extra number to increase or decrease the transparency of your color. Now to differentiate styles and themes, because although they might seem similar and they might be even used interchangeably sometimes, there is a distinction between them, at least in the world of Android or in the world of app development. So style is the property of a view, which means it includes the font, size, color, position, background color, things like that. And themes is a collection of styles. And what makes themes so unique is that once you define them, they'll be applied all over the entire app. And this leads to some uniformity in your app. The user knows what to expect from the color scheme. It won't be as jarring whenever they open a new screen or whenever they click on something or discover a new widget in your app. Instead of applying random colors everywhere in your app and defining tons of new colors each time you want to add a color to some view, once you define the theme, you can directly access the colors from there, and it won't be as unpredictable. So we look at the 10th pathway now. So yeah, Android has its own styling system that lets you control the appearance of all the views in your app. Like I said, you can use view attributes, which include other things like position, background color, tint, and styles, which include properties of views, and themes also. So the pyramid diagram below shows the styling methods which apply the system from bottom to up. So first, the text appearance is applied that particular property, then the theme, then the default style, then the style you define, then the specific attributes of the views. And the higher up you go, those will be overridden by those will override the ones below. So if you set a certain size for the text appearance, let's say you set it to 15 SP, SP being the measurement of the text in Android. And if you set the text size to be again 16 SP in view, then your final view will have 16 SP, not 15 SP, as it's higher up the pyramid as compared to text appearance. So they define each of the levels of the pyramid here. So view attributes is setting attributes explicitly for each view, and they're not reusable because you're setting it for each view particularly yourself. So if you want to reuse it, you have to copy the code you used to set for one view to another view again. Whereas with styles, you can reuse them again and again whenever you want, wherever in your app. And styles, you create a collection of reusable style information such as, like I mentioned in the slides, font size or colors. You can use them again and again instead of as opposed to view attributes, which you'll have to set specifically for each view you design. And the default style is what's already provided by Android. They have their own color scheme, which is already applied if you don't mention your own. You can find this whenever you open up a new Android project. You can go to the styles XML under the resources folder, and you'll see already set up defined colors there. And themes is a collection of styles applied to your whole app. It's used to set the default font, default colors, and even lets you specify the dark and uh, colors for the dark and light mode of your app. So you can have different sets of colors ready to go for both modes because some people prefer the other. So as you can see here, you have two different modes and the text changes color accordingly. So you can set all this in the themes.xml file of your app. There'll be two themes files, one for night and one for light, a day. And this is how you can define all the attributes for a certain style in your app through XML in the layout editor screens. And like I mentioned, an RGB value expresses a color with respect to the intensity of each of the colors, red, green, and blue. And you have the extra 2 digits for representing the transparency of your color. So you can even add your own font, your custom font. You can download it and add it to the font section and use it like that. Then this task shows you that. This is what the defining a style looks like, and this is what defining. And this is how you can use a style throughout your app again and again instead of defining again each time. Yeah, here you can see they're applying the style that you defined above here to the text appearance attribute, and you can define it like this to any other attribute as well, whether it's a button or an image or not an image, sorry, a button or a progress bar or a slider or a switch, anything like that. Now this is the second pathway. So a floating action button, or a fab as it's commonly abbreviated as, is one of the more common UI components in Android apps as well. You must have seen this in other apps as well, where you have a little floating icon. It looks like it's floating above the screen. Maybe it's for an edit button or anything else, or a plus button. So you can add that as well directly in your layer editor. And you can use it just as any other UI component or view. You can add a style to it and a click listener to it. Next, we come to the world of material design, which is a part of Android that lets you customize your own style of apps and let you use that. They have their own website, and you can explore what are things you can do with your components. So we can visit the website quickly. And this is the home page, and as you can see, you can take a look at how to design a lot of components. You can look at yeah, so if you explore the website more, you can see how to style your buttons. You can get different designs for it, different colors, and different ways to make your app look really aesthetically pleasing. Yep, so this is the components page. You can see they have their own. This isn't for Android only. This is just general design. I guess you can say guidelines for different uh, web platform developments such as Android, web, and iOS as well. So you can specifically select Android and see how each of the components have their own way of applying, and you can see how it's used and things like that. So you can look at buttons, for example. And you can look at the implementation just if you want to see how it's used like that. So you can see that they've given the code here, or you can just look how it looks visually and decide which one you want to use, and then look at the corresponding code. So it's a really useful website and tool you can use to make your app look really good. So this is what's known as the toolbar. You'll see this at the top of every app. You can change the color to that, to whatever to fit your style again. And this other two tasks goes into just more of how to define your style or the themes for your app. This is a tool that I found is really useful for any Android developer, or any developer for that matter. So this is a color picker tool, and what you have to do normally is, if you want to define a theme for your app, you have to find the right colors and find the hex codes for them, which is the digit that represents it. And you'd have to add the color and add the certain type of the color name and add the hex code and manage all those certain things. But what you can do here is you can choose the theme for your app with the GUI tool, and you can later on export all the settings you've chosen as an XML file directly, and you can add that XML file to your app, and you'll have the themes file ready to go. So you can choose one theme and see how it is in different contexts. You can see how it looks you can even see how it looks for light and dark, and you can even set the secondary color of your theme. So you'll see certain components change, and once you're done, you can go through You can even look at the accessibility, which is how legible the text will be on these certain colors. You can see here it says not legible, here it says minimum, you can see minimum 55% of capacity, which means you can see it that well. And once you're done with all of it, you can export it either for Android or iOS. And you can see I've got a .xml file here, and you can transport that to your project and rename it themes file, and you have your file ready to go. And lastly, the last pathway. So there are certain languages that are read from right to left, and when you have certain apps or certain phones have features like text to speech or speech to text. So when or screen readers which read out the text on the screen, and when you have certain right to left languages, you can add that as well. So when you have the corresponding language on screen, it will read it in the correct manner instead of left to right. And this is not something you have to do, or it's not something that's expected of you to be done when you build an app, but it's just makes it that much more user friendly, and it makes it more desirable for usage because you've taken care of all the corner cases, and that shows your thoughtfulness or your carefulness or precision about the app. So this is a tool, accessibility scanner, that lets you know how accessible your app currently is and what all you can do to change it or make it more accessible, like changing the color of the screen because the views, because they're not that visible with the default colors and other things like that. So you can see you have suggestions you can apply to make it that much more visible. So right now, if you purposefully made the text completely white, it will suggest you saying that it's not visible. Maybe you want to change the color to something that is visible, and so on and so forth. Next is another tool you can install and use to make sure that you have TalkBack, which is basically Android's version of screen to text, text to speech. Again, this is designed for everyone in the sense that not how to apply design, how to teach design for everyone programming. It's rather designing your app in such a way that everyone can use it. And chips is another widget that appear, like you can say kind of if you've ever used navigation bars, the little components of each page in the navigation bar, they look kind of like that. And you can use that to apply filters or even switch pages. So you can use it as pleased. And here in the context of the GDG app, you can use it to filter out the locations for which you're searching the GDGs in. And this is all the code about how to use the chips and how to display them and how to filter the results based on when you select the corresponding chip. And like I mentioned in the beginning itself, you can have night mode for one of your apps when you set up the themes night file as well, along with the standard themes file, which is takes care of the day mode. And this is what you can do for the night mode. Again, they've talked about the color picker tool because that generates the colors XML file for all the things you need. And yeah, that's it. Again, I keep bringing this up. The DSC solution challenge is a very innovative and interesting challenge to take part in. It's focusing on building solutions for one of the 17 UN development goals that are in plan to finish or to complete. We'll be having a session on it shortly, so be sure to check that out and be updated. And you can start working on an idea or forming a team right now itself and make sure that you're ready for the challenge and the deadline when it comes. These are some useful links for to get yourself equipped with the knowledge for the DSC solution challenge. And these are resources that you can use to continue learning, further develop your learning or your knowledge in Android app development. And thank you so much for sticking throughout the whole course, and I hope you learned a lot. I had a lot of fun teaching, and I hope you had just as much fun learning.